Make sure the sound is working. Yep, looks good, so we're good. Okay, so back to here. We talked about how you can find the secant slope on both sides of the point you're interested in. And then if you make those secant lines shorter and shorter and shorter, the slope of each secant line will get closer and closer to the same value. Another way to think of it is this. So that point over there, let's move it a little bit. Move it up just a little. That's great. Okay. We're trying to figure out the rate of change of the XY pair. Let's get this so the video can see it. So we're trying to figure out the rate of change of this XY pair right here. We're looking to find the rate of change of this XY pair. But we can't really do it. So what we do is we find the rate of change between these 2 points, and then we find the rate of change between these 2 points. Well, that's average rate of change between 2 points. And then we say if we make the points get closer and closer together by doing this, so we move our H, which is where to go? Right there. So we move the points closer and closer. It doesn't work on that screen, so we've got to go back out. Hold on. So we get the points to move closer and closer, like this. And as we do that, you should be paying attention to these slopes right here. Look at this slope. It's currently at 14. This slope is 7.6. But as I make the secant line shorter and shorter, the secant slopes become closer and closer to the same value. And essentially what I'm saying is, hey, I'm going to calculate the average rate of change between points. And as I do that, if the points get closer and closer, I'm going to have a more and more accurate measurement of the actual rate of change at that point. That's what I'm doing. And so I just make them closer and closer. The closer they get, the better my measurement. My measurement is more and more accurate the closer and closer that the points get to each other. And we say that if we could do it forever, we would actually be able to calculate how fast the XY pair is changing right at that one point. We get really, really close. Come on, can't get the pen to stop on point 1. That's pretty good. 0, no, point 1. Try again. Go to the computer. There we go. So here are my 2 slopes, 11 and 10.9. So right between them is 11. That's what we declare the rate of change to be right at that spot. So we talked about that last time, correct? Okay. We then went to the packet and we started talking about this problem. I cannot remember if we kind of exhausted our conversation about number 1 or we just kind of got started. We got halfway through. We did a little discussion on it. Give me some feedback as to where we ended up. Lots of blank looks.
Well, in the last class I attempted to solve it, and we left off.
So kind of got working on it, but not per se completely analyzed it. Ish. Something like that. 2 more for Caden. So let's talk some more here. Okay, now we had in A1 today, interesting discussion. And I'm kind of anticipating the same thing in A2. Today really is all about language. Okay, it's like you have to be extremely precise, otherwise you will not be talking about the right thing. You can't be casual at all. Here's what we're going to do now. Here's F. I think we kind of did this last time as well, but we'll just do it again. We could say over here, let's go look at this point. Okay. When you look at F, you've got to keep track of several things. You've got to keep track of the XY pair that corresponds to that dot. So Naomi, what's the XY pair that corresponds to that dot?
-2.
Appears to be about -2, 1. 2 points for Naomi.
If they give you
Okay, that's one thing you're keeping track of, is the XY pair. But now, we are interested in doing the Desmos thing, and we're interested in saying, hey, if we slide the point over there, kind of like this, but this isn't going to be exactly the same because the graphs don't match perfectly, but we want to know what the slope is kind of over here. Well, the Desmos will tell us that slope is negative 14. We don't have Desmos to help us here, so all you're expected to do is look at that dot and say, well, if I, drew a tangent line right there, and remember that the tangent line is really created by drawing two secant lines and then making the secants closer and closer together. So they start out as two distinct secant lines, but as they get closer and closer together, they essentially end up matching the tangent line, something like that. That's all you're expected to do on this picture, is say, hey, I drew a tangent line right there. That tangent line will have some slope. So let's indicate that. So that tangent slope right there, you're not expected to come up with a number. You're just expected to notice whether that tangent slope is positive, negative, or 0. So just say it as a class. Is the slope that I just drew, so I drew a tangent line. That tangent line has a slope. Is that slope positive, negative, or 0? Say it.
Negative.
Negative. Pretty good. Cool. So I don't know the number, it's just negative. I mean, I guess I could get all sophisticated with Desmos here, and we could make this match up with the other graph, and we could find the exact value. I think we could do that real quick, just for the heck of it. So if I sit over here by CJ, zoom back out. So you want to zoom in. So this up here, to make them match, this needs to be like a 0.5. Come over here, and then we're going to come in really close. We'll move the dot closer. Mouse to work. Way down in here, about -2. Perfect. Let me zoom in and look at it.
So, when I come around and just grab your notebook really quickly. You don't have, make sure your name's on it.
When those dots get really close together, the slope there actually is turning out to be about exactly -2. So we could do that, but you really aren't expected to do that. You're just expected to look at the picture up here. Note that if you drew a tangent line right there, the slope of that tangent line would be some negative number. Question or confusion from anyone about anything? Awesome. Okay, then you would come down here and say, these are values of f prime. And therefore, if I've got a tangent slope up here that's negative, when I come down here, I have to find a y-coordinate that is negative. So I go to the same x, -2, and I find the y-coordinate down here on my f prime graph. And there's this one here. This is about -2, comma, I don't know, about -1.5. Okay, if this really is the correct f prime graph for this f graph, this would be telling you that the slope right there is 1.5 negative. That's what this is telling you. Questions? Cool. Keep going. Easy question? No, just okay. Over here, by comparison, if I label this point is at -2, comma 2.
Clear your desk, besides everything you're in that car.
And that would be telling me that the slope up here at x equal -2 has a value of +2. That's what this graph is communicating to me about that graph, if this is the correct f prime graph. So hands up. One of these can't be right, because this says the slope at that moment is negative 1.5. This says the slope at that point is positive 2. Which one is wrong? Hands up. Which one is wrong? Let's go Oakley.
B is wrong.
So B is wrong because it's showing positive slope when clearly that slope is negative. So this one can't be right. 2 points if you knew that. You got curiosities or questions about anything? All you're learning to do, all you're really learning is, we spent some time here. 2 points for CJ for good question. All we're really learning, I gotta zoom this back out. We use Desmos to show you what tangent slope means. But once I show you what tangent slope means, you really don't need the Desmos thing anymore for what we're doing. Because they're not asking, wow, that's interesting. They're not asking you to actually calculate slopes. They're just asking you to get a general sense of what the slope is doing. And so we really didn't need the actual number of the slope. We just needed to clearly understand that we are looking at a negative slope. Let's make this a little bit smaller so the dots get closer together. There we go. Get rid of that. Okay, come back to here. We also have to make sure we know how to write all this stuff. So let's practice writing it down. I cannot remember how much of this we did last time. One way to write all of this stuff is with a table like this. This dot is at negative 2, 1. So you could label that. You'd say, okay, my x-coordinate's negative 2. My y-coordinate is positive 1. But now I also want to talk about the slope at that point right here. This slope. So the slope of that point is some negative number. We don't know exactly what negative number it is, but we know it's negative. Questions? Okay, another thing you have to be able to do is this. Make sure you write this in your notes. Remembering all this is not going to be trivial. The table, I would make a little table. I would draw that in your notes. This is the new way to say the slope of f, because look, it's a ratio. Slope means rise over run. This is finding the change in f divided by the change in x on an infinitesimal level. And we're doing it at x equal negative 2. And we're finding that at that x-coordinate there is some negative slope. We don't really know how negative it is yet, but there is some negative slope. Questions? Just watching your pencil so don't go too fast.
What are you going to do with this once you get it? Put your name on it. That's the next thing you can do. Put your name on it right now.
Cool. This symbol also is relevant. The other way to write it is like this. You say f prime of negative 2 has a value that is negative. That's why this so far is okay. That's a value, f prime at negative 2, that is definitely negative. Solid. Okay. All right, we know B is wrong. If we go here, Zach Edwards, if this kind of has to keep going somehow, so we'll just extend it a little bit. Come down here, we put a dot. What's the xy coordinate of that dot, Zach? Negative what?
Negative 4 and 5.
Negative 4 would be way over here.
Oh, wait, what are you asking?
What's the xy coordinate of that dot?
Oh, negative 2, negative 4.
That sounds better. Maybe 3, I guess. 2 for Zach. Okay, that would mean that up here, the slope at x equal negative 2 would have to be negative 3. That would be the slope. That's possible, so I guess that could still work. If we come over here, we'll go to Micah. What's this XY pair, Micah? Best you can tell.
-2, -2.
-2, -2. That would be reasonable because this slope is negative. So these three still are all reasonable choices to match this if you're just looking at that one point. Okay. Questions? Please.
If A is the right answer, is it because it has a matching graph, or?
A is not the right answer, but we don't really know that yet. We're looking to make sure that at every single point, see, the idea is this, two for CJ. On one of these graphs, this one, or this one, every single y coordinate is supposed to accurately show the slope of that graph. So every single y value on this graph is supposed to accurately show the slope of that graph. So let's see how many people can answer this. Can you find a point on this graph here? Oops, wrong button. Can you find a point on this graph that doesn't match this graph? Just one point. That's all you got to do to eliminate it as a possibility. Hands up. Is there a point on this graph here where the y coordinate is not representing the slope of this graph at that same x coordinate? There we go. That's nearly everybody. Nicely done. Let's go, Rachel.
0, 1.
So if I come down here to x equal 0, 1, 2 points if your hand was raised. Okay. Somebody raise your hand and tell me, how do you read that? Like, what does 0, 1 here, what does 0, 1 here mean up here? Hands up. What does 0, 1 mean on this graph in terms of this graph? About a third of you. Let's go, Cole.
That the slope's positive,
Where?
like at 1
Oh, close.
or negative 1.
You got the right idea. I just got to get you to say it different.
Okay.
No, you're okay. So this is referring to an x-coordinate. The x-coordinate is always the same. So whatever x I speak of here, I'm speaking of the same x here. So if I'm talking about x equals 0 here, I've got to go up here to x equals 0, which would be this spot right there.
Okay, so like at 0, then the slope's positive.
Perfect. This says at x equals 0, on the f graph, the slope at this spot needs to be, the slope of the line tangent at that point needs to be a positive 1. That's what this is saying. Any have questions about that? 2 for Cole. Okay, so just say it together. There's a clash, yes or no. Is the tangent slope at this point where x equals 0 on f a value of positive 1? Say yes or no.
No.
No. What is the value of the slope on f at x equals 0? Say it.
0.
0. Everybody comfortable? Okay. If it feels like we're spending a long time on this, it's because this is not a small idea that you use for a few questions in one packet. See, and then you do kind of a couple of test questions, and then you never see it again for the rest of the year. This is the foundation of everything we do. Like it's like, talk about limits for 3 packets. Limits are 10 times less important than what we're doing today, easily. Like as far as like what you get graded on the AP test. So you have to get very good at understanding and feeling very comfortable with how f compares to f prime. Is everybody good? Questions? Awesome. So this one is wrong. This is not the right answer. We can eliminate this. We're down to 2 choices. This graph or this graph. That's all we have left. Okay. Kind of like before, we can just find a point that doesn't work. We can eliminate one of the 2 graphs. So hands up, who can see a point that doesn't work? can see a point that will not work to make one of these a match for this F up here. So if your hand is not raised, talk to someone who's nearby you who has their hand raised so that you can raise your hand as well. I want to really get everybody. Best we can.
That's so weird, like speaking for like that last one, like when you kept you're like, for sure it's not. I literally crossed it. What's on this side? On this side. Yeah, it wouldn't let me work. Wait, sorry,
No, but 9 of us from last year's Olympic
Okay, hey. So, I got deep into helping CJ. I forgot the question on this. What was the question again?
We're looking for a point that disproves either C or D.
Perfect. Hands up. Who knows a point that disproves C or D? Who knows a point that disproves C or D? There we go. Let's go, Noah.
1, 0.
So 1, 0 on which?
On that one, yeah.
On C?
Yeah.
So if I go to 1, 0 on C, by the way, everyone gets 2 points for participating in that little discussion there. So I go to this point. What's the XY pair right there, Noah? 1, 0. Thank you for saying it again. Apologies for asking it twice. Okay, 1, 0. Okay, pick on somebody at random. We'll try Ruby. Ruby, when I look at this X, it's telling me to think about something up here. When I look at that X value of 1, what am I supposed to be thinking about up here?
The X value on that graph. And
Perfect, perfect, perfect. Sorry to jump in the middle, it's perfect. So I'm supposed to go to X equal 1 on this graph, which would be right here. 2 points for Ruby. So I go to the same place, and we'll jump over here to Riker.
Yep.
The 0 value on this f prime graph says I should be looking at what characteristic up there?
The 0 on the graph C is telling you like to look at the tangent slope on graph f of x.
Perfect. 2 points for Riker. So I come up here to graph F. I draw a line that is tangent, best I can, at that point. Still missing. Try one more time. Still low. Like poor news calibration. So I look at the slope of that line tangent. That slope is clearly not 0. So that's why this cannot be the correct match. It has to match point by point. Questions? Cool. Okay. Let's look at a couple of the connections then. Let's start over here. Okay. We need to talk about a few more characteristics that we see in this picture. So right here when we look at F, there are a bunch of XY pairs. Now the X values, we always read graphs left to right. So the X values are definitely increasing as we read the graph. When we talk about F, we also want to talk about what the Y values are doing. So as you look at these Y values, raise your hand, what are they doing? Like if you look at one Y value after another, what are they doing? Hands up, everybody. One Y value after another. What are they doing? Just waiting for Tate to jump in, he's almost there. What are the Y values doing, Tate?
Getting closer to 0. Or negative.
Kind of. Like if I go to, like this Y value here, Tate, what's this Y value as best you can tell?
1.
Good. So then I move to the next one. How does this Y value take compared to this Y value? Yeah, it's less, right? How about this one compared to this one, Tate? Decreasing. How about this one compared to this one? Still decreasing. Raise your hand, be honest with me. How many were going to tell me that as you look at all these points, the Y values are decreasing? Show me, how many thought that? 2 more, okay. So all along here, the Y values are decreasing. The Y values of F. The Y values of F are decreasing. Hands up. At what X coordinate did the Y values of F stop decreasing? Hands. At what X coordinate did the Y values of F, Kelly, stop decreasing?
0.
So at X equals 0, the Y values of F stop decreasing. If you knew that, give yourself a point. Then the Y values of F begin to increase. Okay, that's what the Y values are doing. Now we look at the slopes at each point. So if I look at the tangent line slope right here, hands up everybody, what could you say about that tangent line slope? Just that one slope right there. That's a tangent line. I want you to say something about that one slope. Here we go. Let's go, Marley.
It's negative.
So that slope is definitely a negative tangent slope. 2 points if you knew that. Now go to the next one. What could you say about that yellow tangent slope? Hands up. Let's go, Cohen.
Still negative.
Still negative. 2 points if you knew that. Cohen, how does the yellow tangent slope compare to the green tangent slope?
It's just it's like greater. It's like less. Wait, I don't know how to.
You're okay. I get you. It's tricky with negatives. Tricky with negatives.
It's not decreasing as much.
You're good. Let me say it back to you. So one more time, Cohen. The tangent line slope of the green is positive, negative, or 0? Good. Tangent line slope of the yellow, positive, negative, or 0? Negative as well. Which of the two is more negative? So it's actually the green.
Yeah, because it's going down.
Yeah. Is that okay?
Yeah, so it's kind of.
Yeah.
Mr. Smith, is it because it has more of a severe slope?
Correct. 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 if you look at a line, hey, just say it as a class. Is the slope of that green line positive or negative? Say it.
Negative.
Negative. And then you draw something like this. Slope of that yellow line, positive or negative?
Negative.
Negative. Which is more negative, green or yellow? Say it.
Green.
Green. Good. Two more for CJ. Keep going. So we'll go to the red here. Jane's going to help us. Jane, how about that red one? What's the slope of that?
Negative.
Negative. How does the red slope compare to the yellow compare to the green?
It's less negative.
Less negative. Less negative. Are you with me? Two more for Jane. So here's a weird thing. Again, I told you at the beginning, you've got to be very precise in your wording, or you'll get mixed up very quickly. That's why it says of right here. We've got to keep track of, are we talking about F or F prime? Are we talking about X coordinates, Y coordinates? We also have to keep track of this. There's a difference between tangent slope and tangent line. Tangent slope is a number. Tangent line is a set of points. Okay? So the tangent line slope of the green is negative. The tangent line slope of the yellow is a little less negative. Don't move on me. The tangent line slope of the red is even a little less negative. Okay, so we're going from negative slope to less negative slope to less negative slope. Hands up, everybody. From one slope to the next, would you say the values of those slopes increase or do they decrease? Hands up. From one, you're talking about three different slopes, green, yellow, and red. Do the values of those slopes increase or do the values of those slopes decrease as we go from one to the next? There we go. Nice. Let's go Lennox.
They increase.
So because they're going from negative value to less negative value, keep doing that, to less negative value, the values of the slopes are definitely increasing. Be honest, how many knew that? Two more, okay. Maybe want to talk more about it if you can't see it. It can be a little confusing because of this. Look, that green tangent line, not tangent slope, that green tangent line is decreasing. That yellow tangent line is decreasing. Those points along that yellow line are decreasing. That red tangent line is decreasing. But the values of the slopes are increasing. Two different things. Comfortable? Okay, hands up. Bit of a trick question. At what x coordinate will the values of the slopes stop increasing? Like I go along here, there's another slope, there's another. Keep drawing little tangent lines and calculating the slopes at each tangent line. Trick question. At what x coordinate will the values of the slopes of f stop increasing? Hands up. At which x coordinate will the values of the slopes of f stop increasing? Let's go, Ryan.
It never will.
How many knew that? Nicely done. Never. Like right here, 2 points if you knew that. We'll go to Naomi, help me. Naomi, what's the slope of the purple?
0.
Perfect. How about the slope of the green? Positive or negative?
Positive.
Positive. How about the slope of this blue over here?
Positive.
More or less positive than the green?
More.
More. So along here, the slopes are becoming less and less negative. Therefore, the slopes at each point are increasing. Along here, the slopes are becoming more and more positive. So the slopes are always increasing along there. Always increasing. Questions? Cool. Okay, connections. Let's erase and start over. So the first year I taught calculus, I went through this kind of an idea, and we use it all throughout the year. At the end of the year, as we were practicing for the AP test, I was helping a student after school. She was sitting about where Marley is. Her name was Danica Wright. And as I was helping her, she had written something on her paper that is on your reference sheet. So look at your reference sheet. Look in the top left corner of the reference sheet. There's a little table. That little table looks kind of like this. Mine's a little bit busier, but you've got essentially this part here. Okay, she had drawn that on her notes, and I asked her name was Danica Wright, and I said, "Hey, where'd you get that?" And she just said that as she'd been practicing AP problems, she noticed that it seemed like about every fourth problem, she needed this information to just help her more quickly solve the problem. And the correspondence she noticed was this. One more time, here's F. Are the values of F increasing or decreasing? Say it. Decreasing. Are the values of F increasing or decreasing? Say it. Decreasing. I feel like I'm getting a mix. I can't tell. Are the values of F increasing or decreasing? Decreasing. No. So the values of F are decreasing. It's okay. The values of F are going down because the values of F are the y coordinates. So all along there, the values of F are decreasing. Ends up, where did the values of F stop decreasing? Where did the values of F stop decreasing? Let's go, Ava. So at x equals 0, the values of F stop decreasing. That's accurate. 2 points if you knew that. Then the values of F increase. That's the values of F. Okay? Say it together as a class. If I look right here and I draw a little tangent line, is that tangent line slope positive or negative? Say it. Negative. Good. I draw another tangent line slope. Positive or negative? Negative. I draw another tangent line slope. Positive or negative? Negative. Trick question. I draw another tangent line slope. Positive or negative?
Nothing.
0. Good job. Are the values of these tangent line slopes increasing or decreasing? That was weak, but at least it was correct. Are the values of those tangent line slopes increasing or decreasing?
Increasing.
They're increasing. So we need to talk about it more. Make sure you can, you have to see it. You can't just memorize what I say. You've got to make sure you look at it and go, that makes sense. If it makes sense, your memory will retain the information. If it doesn't make sense, you'll forget it very rapidly. Cool. All right. So all along here where F is decreasing, every time I draw a tangent line slope, that tangent line slope has a negative value. That is fact. It will never change. Danica documented that in her little chart. She said, hey, if the values of F are decreasing, then every time I calculate a slope of F, that slope of F will have a negative value. So the values of F prime will all be negative. That's what she figured out when we did this thing. This slope is negative. This slope is also negative, also negative, also negative. When F is decreasing, the slopes of F are negative. When F is increasing over here, every time I draw a tangent line slope of F, every one of those tangent line slopes will be positive when F is increasing. That's right here on Danica's chart. Questions? Cool. Oh, Izzy, please.
Can you just say that again?
Yes. I'm going to have you say it with me, Izzy. It'll stay in your memory better. Is that okay?
Yeah.
We're going to practice over here. So we're going to pretend this is no longer F prime. We're going to pretend this is F. So we can just practice for a minute, okay? Let's get everybody to do it together so that Izzy doesn't feel all the pressure. Okay. Right here, as you look at the dots right here in this region, would you say that F is increasing, decreasing, or neither? Say it. F is definitely increasing. The dots are going up. That means if I go check the rate of change, like how we change from one dot to the next, since the dots are going up, would you say the rate of change is positive, negative, or zero?
Positive.
Positive. The dots are going up. That's all this says. When the dots of F go up, the rate at which those dots change must be a positive number because they're going up. We can see it as well by saying, hey, if I draw a slope here, that slope will have definitely a positive value. So whenever F is increasing, the slope of F must be positive. Can't tell if that was your question, though.
Yeah, I was just confused what the table was saying.
Over here.
I just didn't, yeah, I like didn't understand what you were circling for what.
Oh, gotcha. Let me do it one more time. We'll stay here as long as you need. It is no joke that when you get to the AP test, you're going to draw this like about every fifth problem, like over and over again, so it's got to be pretty clear. When I circle this column, and I circle this, I'm talking about the Y values on the F graph. That's all I'm referring to when I circle this and this. When I circle here, I'm actually talking about two different things. I'm talking about the slopes at every point on F, but I'm also talking about the Y coordinates at every point on F prime. So this symbol means two different things, depending on which graph you're looking at. If you're looking over here at the F graph, like here at, say, 1, then I'd be looking at what is the rate of change right there. What's the rate of change? Well, the dots are going up. So the rate of change at that spot has to be a positive number. F prime means the rate of change of F. But if I plot that on my F prime graph, which we found to be this one here, I'd say, hey, that slope is a positive number. That means my F prime value is a positive value. Can't tell, helping or not helping.
Yeah, it makes more sense. But
That's good. Keep talking.
it's still confusing. I don't know why that's like I don't get how they're both like the same positive, they're not the same.
So whenever we look, let's clear this off. Whenever we look at, two more for Izzy. Whenever we look at a point on F, we can choose any point we want. So Hannah, choose a point on F, I don't care.
1.
X equal 1. If I look at that point, and then I look at Danica's chart over here, I'm investigating the kind of points in the vicinity. And I want to know, as I look at those points, do I see those points on F going up or do I see them going down? That's what I'm looking for. So everybody say it together. Right here on F, in this vicinity, are the values of F going up or going down? Say it. They're going up. They're increasing. That's what that means. But in order for the values of F to increase, that means they must be changing. And if they're going up, they're changing in a positive way. Their rate of increase is positive. That's why we say this column, see this word here, amount, is referring to just the values of F. This column refers to how fast those values change. So if they're going up, those values must be changing in a positive way. That's the values of F prime. Other questions? Let's kind of keep talking. Let's keep doing more examples. It will usually help. Okay, so you do need to memorize that. Danica's chart part there. We've talked about this. Okay, we started talking a little bit about the other part. We'll do it some more now. So let's go to, we said that if you looked at each slope of f, so you're no longer looking at the points of f. Like the points of f, they decrease for a while, and then the points on f, the y values, then they increase. That's why down here on f prime, the values of f prime are all negative for a while, and then the values of f prime switch and become positive for a while. Like that. Questions on that? Well, very quiet today. I'm not being very successful at getting people to ask questions, but we'll keep working on it. Next thing we can look at is, if we investigate slopes of f, we'd say this slope of f is negative, but then this slope of f is less negative, and then this slope of f is also less negative. This slope of f is, again, even more less negative. So we said the slopes of f are increasing, and they never stop increasing. As we go here, the slope of f is positive, and then the slope of f gets more positive, and then the slope of f gets even more positive. So we would say that the slopes of f, that's what f prime represents. F prime is a symbol that represents the slopes of f, the rates of change of f. They are always increasing. All those slopes are increasing. Well, when a curve has slope that always increases, we say that that curve is concave up. You should have studied concave up last year. Okay? When the slopes are increasing, that's what concave up means. Questions? So Danica put that into her chart as well. That when f is concave up, that means the slopes are going to be increasing. Little by little. Vice versa for concave down. Cool. Okay, last thing is the connection here. Okay, we know that if the values of f are increasing, then that means every single slope that we measure on f is going to have a positive value. F prime are the slopes on f. Okay, look at this symbol, f double prime. F double prime means the slope of f prime. F double prime means the slope of f prime. It's not new, you're just doing it again. So we figured out that this graph here is the correct value graph for f. We have figured out that the correct f prime graph is right here. If we wanted to plot f double prime, we would come down to f prime and measure the slope of f prime. We would check the slope of f prime here. Say it together. Is that slope positive or negative or zero? Say it. Positive. Positive. That slope is positive. Then we would check the next slope on f prime. Positive, negative, or zero? Positive. Positive. We check the next slope. Positive, negative, or zero? Positive. F prime is always increasing. So the y values of f prime, you have to keep switching back and forth. I was talking about the slopes of f prime, now I'm talking about the y values. The y values, the dots, are going up. That's why every slope of f prime is positive. Because if f prime is always increasing, then every slope of f prime has to be a positive value. That's why it says here that when f prime is increasing, every slope of f prime must be positive. Okay? The slopes of f prime are positive? Raise your hand for this one. Are the slopes of f prime increasing, decreasing, or doing some of each? Hands up. Are the slopes of f prime increasing, decreasing, or doing both? Trick question, actually. Are the slopes of f prime increasing, decreasing, or doing both? And it's kind of a trick question. Let's go Zeta. So the tangent lines that I draw are definitely increasing. Like this tangent line in green is increasing, it's going up. This red tangent line also going up. This blue tangent line also going up. 2 more for Zeta. However, the question I asked was slightly different. The question I asked was, what are the tangent slopes along there doing? What are the tangent slopes of f prime doing? Hands up. What are the tangent slopes of f prime doing, Brecken?
Staying consistent.
There we go. How many knew that? 2 more. The slopes of f prime, the values of the slopes are constant. The slope of f prime isn't changing. Lennox.
Just on this paper, for F it says concave down, but then I think it was increasing right there on this one. Yeah, I just read it.
Oh, thank you. That's just a typo. Fix that, everybody. Oh, no, wait a minute. Did yours just print that way? Oh, I got it. There's 2 I's on the table. It's supposed to be a D. Yeah, right here. Thank you, Leonard. That D on your paper is wrong. It's an I. You just need to change it to a D. The one that the letter that's associated with concave down, a nice guy, got typed wrong. It's supposed to be a D. It's not an I. So conveniently changes easily.
On the test, are we allowed to use a number?
You are not. Good question, CJ. So the AP test does not allow any sort of reference material, no note cards, nothing. So if I let you use a note card now, I'm doing nothing but making it harder later. If you memorize it now, it will stick with you far better throughout the rest of the year because you'll have to keep using it. So yeah, this is to help you learn, but no reference card on the test. Good question. Please, Carlos.
Is this just for the first test or is this
So this reference card is what you'll need for the first test. You'll also need it for the third test, and you'll also need it for the AP test. So it sticks with you, but we don't use it for like and then we use a little bit on Unit 4 as well. So it kind of carries with you the whole year. We will add to it. It's just the start. So 2 more for Marley. Okay. Clear this off. Okay, so the way the chart works then again is if you see, here's f prime, and we see that all slopes of f prime are the same. That means if we were trying to draw f double prime, the graph of f double prime would look something like this. It would be a bunch of dots whose value never changes. And they have to have positive y values because the dots of f double prime are telling us the slopes of f prime. So if f prime has a slope that is never changing, that means f double prime must have y values that never change. Questions? 2 points for Ava. Any feedback is very appreciated. Blank looks are hard. Rachel, please.
Sorry, how do you tell like that the slopes are like the same?
Oh, awesome. So 2 more for Rachel. You really are expected to simply kind of look and see if it's, like you're not supposed to calculate anything. You just say, hey, if I looked at this spot and I drew a tangent line, that tangent line is going to have some slope. If I move to a different spot and draw a different tangent line, you're then expected to visually compare the slope of each tangent line. Does the black tangent line appear to have the same or different slope as the green tangent line, in your opinion?
The same.
They're the same.
Okay.
So if I do that everywhere on this graph of f prime, I get the same conclusion. The slope at every point is the same, and that's true because it's a linear function.
Okay.
That's the definition of a linear function. The slope never changes. It's always the same. Did that answer your question?
Yeah, thank you.
Two more. Anybody else? Okay. Danica's chart makes a convenient jump. You could say, oh look, f of x is concave up always. That means when I go look at my f double prime graph, I must find a graph whose y coordinates are always positive. And we did. Because every one of these slopes has a positive value, our graph of f double prime is definitely going to be a graph where every y coordinate has a positive value. That's consistent with Danica's chart. Like that. Questions? Oh, please, Ava.
How did we get to that conclusion on the graph that if it's concave up, that all of the f double primes are going to be positive?
Oh, awesome. So we did it kind of little by little. We said, here's f. Good there. We said, let's look at what the slopes of f are doing. So as we go here, to here, to here, hands up everybody. What are the values of the slopes of f doing as we read the graph? Are the values of the slopes increasing, decreasing, or staying constant, or kind of changing up and down? Hands up, come on. What are the values of the slopes doing as we read the graph, Zach? The question is, we look at f, we check the slope at each point on f. And we want to know as we go, we check this slope value, and then we check this slope value, and then we check this slope value, etc. Do we see those slope values increasing, decreasing, staying constant, or always, I guess that would be it, like increasing, decreasing, staying constant, or are they varying up and down? So let's check it. 2 points if your hand is raised. So this slope right here, Zach, positive or negative? Perfect. It's a little hard to calculate how negative it is. So I'm just going to make up a number to make talking easier. I'm going to say that's negative 10. That is completely wrong, but it's good enough to kind of get the idea. So Cohen, this slope, positive or negative?
Negative.
Is it more negative than negative 10 or less negative than negative 10?
Less.
Less negative. So we'll say like negative 8. 2 points for Cohen. Tate, this slope right here, positive or negative? Negative. More or less negative than negative 8? So that's maybe like negative 6. And we go to Zach. The slope right here, Zach. What's that slope going to be?
0.
That one's 0. 2 for Zach. We'll go over here to Jared. This slope right here, Jared. Positive or negative or 0?
Positive.
That one's positive, so we'll say that's about like that. We'll say it's 6. And we'll go to Cash Dowdle. Cash, this slope right here,
Positive.
more positive than 6 or less positive than 6?
More.
More positive than 6. So like maybe 8. So as you look at the values of the slopes of f, hands up everybody, are the values of the slopes of f increasing, decreasing, constant, varying? What are they doing, Zach? Those are definitely increasing. How many do? 2 more. So the slopes of f are increasing. You can confirm that by just looking at the curve of f. It says if f is a concave up curve, then the slopes of f must be increasing. If f is a concave up curve, this, oh please Ruby, save me. Oh no, just stretching. I'm still not saved. It's all good. Questions? Oh. So then what we did is we said, okay, if the slopes of f are all increasing, that means when you look at f prime, you have to see y values that go up. The y values must go up, and they do. The y values are climbing down here. So that makes sense. The y values go up. But if the y values of f go up, that means f prime, that means f prime is increasing. If f prime is increasing, the rate of change of f prime must be positive to cause f prime to go up. The rate of change of f prime is f double prime. So if f prime is increasing, the values of f prime are going up, the rate of change of f prime must be positive. That's kind of the little by little method. Danica, again, built a chart so she could do it faster. She could say, hey, if I know f is concave up, then I know automatically f double prime must be positive. Okay. 2 more for Ava. Any other questions? Like we're hammering it to death, putting you all asleep. Ruby?
So is it basically that in that chart it's just saying what your graph is going to look like? So like the last one is just going to be positive, so it's just going to be a straight line positive. The other one's increasing, so it's going to be a linear positive slope, and then the other one's just concave up.
So 2 points for Ruby. Half of what you said was right, a half was not right. So we'll fix that, no big deal. Hey, look up, everybody. One of the smartest things you can do in this class is talk. It really is. Because if you say something and it's correct, I can confirm it, then you feel really solid. If you say something that's incorrect, I can just let you know, hey, that part's not right, we need to fix it. If you don't say anything, you can't do that. Like the learning slows way down when you just listen. The more you interact, the better you'll learn. Perfect. So let's kind of fix a little bit of that, Ruby. Let's go to a slightly different example that will help. Go to, so in your blue packet, turn to number. It's going to be a ways in. I got to find it. Keep going. Almost there. That'll work. 31. So look at 31. You notice that 31 says the same thing again. It says, which of the following graphs could represent the slope at every point of the function graph below? So it's showing us f of x, and they're asking us which of the ones below is f prime. So kind of trying to follow what Ruby was going through there. Let's pull out Danica's chart. Everyone in the room, raise your hand. If you're following Danica's chart, let's just go across the page. We're looking at f. So we're looking at f. We need to figure out if f is always increasing or only sometimes increasing. Just say it out loud. Always or sometimes?
Sometimes.
Perfect. Raise your hand and tell me, when does f stop increasing? Hands up. When does f stop increasing? There we go. When does f stop increasing? Let's go, Cohen.
When x is like 0.43.
When x is about 0.4. That's a good job. Somewhere in here-ish.
Yeah.
That's well done. Please raise your hand if you were looking at the same point that Cohen pointed out. 2 more. Good. So f is increasing here, which means if I'm checking the slope all along there, it's like the Desmos thing. Look, you're following a part of a curve that's going up. And as you do that, every time you check a slope, like here's the slope right here, 8. If you keep going along the curve, you're just going to keep finding positive slopes. 13, come back down here, that slope is 2. Every time f is going up, the only way f can go up is if the slope or rate of change of f is positive, causing f to go up. So that's this part in Danica's chart. That means when you go look at f prime, you have to find y coordinates that are all positive values. And they have to match up in the same window. So up here we're looking at, from about here to here. In that window, f is going up. Therefore, in that window, every value of f prime must be a positive number. So hands up. Who can tell me? Wow, I can eliminate a lot. Which ones can be eliminated? Hands up. Which ones can be eliminated? There we go. Let's go CJ.
A, B, and D.
So if I go to A, I go to the same window. So it's kind of like here. I'm supposed to find inside that window all positive values of f prime, because every slope on f is positive in that window. But these values of f prime, they're all negative. These negative values of f prime would be telling me that f would be going down. But f is not going down, f is going up. So A is clearly wrong. Please raise your hand if you honestly knew A was wrong. 2 more. Okay, cool. Hands up again. What else is wrong? There we go. Let's go, Olivia.
B.
So Olivia goes over here to B. B shows f prime always being negative. That would mean f, at least in here, that would mean f would have to be going down. But f is clearly going up. Now, how many knew that one? 2 more. What else is wrong? Oh, yeah, trick question. What else is wrong? Trick question. Trick means it sounds funny that I'm asking the question. Let's try Sam.
D's wrong.
So if I go to D, so I was going to disagree with that. Why did you say D was wrong, Sam?
Oh, I said D because at 0 the slope is negative.
Oh, gotcha. You went further along. I gotcha.
Yeah.
No worries. So you went to here and said, okay, in this little window we're fine, right?
Oh, yeah.
Yeah, in the window we're fine because the values are always positive of f prime. But then Sam went further along and said, let's see, at x equal, oh, like right here. 2 for Sam. Hands up. What's the slope of f right there? Hands up. What's the slope of f right there? Let's go, Oakley.
0.
How many knew? 2 more. So that means I need to find what down here? Hands up, everybody. What must I find on one of these? Are both wrong. What must I find on one of these graphs? What must I find? Let's go, Ruby.
Is it where your y is 0 because that's in your slope?
Perfect. So this x coordinate is about negative 0.5. That means down here, I must find at an x coordinate of about negative 0.5 a y value that is 0. So the correspondence is perfect. How many saw that? 2 more. That's what Sam was. Got that one, Sam? Okay.
Yeah.
That's how he knows this one's looking good. This one is not. This one's showing the wrong slope value at that point. I'm still not quite to Ruby's question, but we're getting there. So this is f. This is f prime now, the correct f prime. If we went to plot f double prime, we would now have to say, okay, just say it out loud. We're finding the slopes of f prime. Is this tangent slope of f prime positive, negative, 0? Say it.
Negative.
Negative. How about this slope of f prime? Say it.
Negative.
How about this slope of f prime?
Negative.
That means when I draw f double prime, I have to draw dots that are all negative. Are these slopes increasing or decreasing? Say it.
Increasing.
Nicely done. Increasing. So my dots on f double prime have to go up. So they are, like if I'm drawing f double prime, they're going to be negative dots that go up. Right there, 0, because this slope of f prime is 0. I don't know that I really answered your question, but it felt like I gave a little more variety. You good?
Yeah.
Okay. Other questions? Oh, please, Izzy.
I'm confused how A and B don't work because for like the F, like the first graph, it's like going up, and then A and B are also going up in that like same block size circles.
Gotcha. Bell's gonna ring in 1 minute. I'm gonna have Izzy come to the front. Anybody else who wants to come to the front, we'll talk about it. But before we do that, I gotta stop my recording.